Now, in this lesson, we're going to review this idea about magnets and how magnets are made. Let's read the question together. Sally coiled a wire around a metal nail. Both ends of the wire were attached to a battery. What does she mean here? Right? She coiled wire around the metal nail and both ends of the wire were attached to a battery. Right, let's see, did she attach them correctly? So one end of the wire is connected to the minus sign part of the battery, the negative side, and at the positive side of the battery here there's another wire attached to it. So I can tell that this wire has been connected properly, correctly, and an electrical current should be able to flow through this wire. Then there's a metal ball bearing was placed near the metal nail such that the nail was within the magnetic field region. Now ball bearing is just think of it as a metal ball, don't care about this bearing. So this is a metal ball. Now take note that the word here is metal. Alright, and there are different kind of metals. Some metals are magnetic. Some metals are non-magnetic. Magnetic materials, metals that are magnetic are things like iron and steel. Metals that are non-magnetic could be aluminum, could be copper, or anything else. So let us be very clear. We do not know whether this metal ball can be attracted to the electromagnet or not. By now you should be able to tell this is an electromagnet. Right? We should be able to tell. Will it be attracted to it or not? We will know until we see the observation. Similarly, there's a metal nail here. Now, this electromagnet will work if this nail is a magnetic material like iron or steel. If it is a non-magnetic material like copper or aluminum, then even if current can flow through, this will still not become an electromagnet. So far, what we have done is trying to understand this picture, this story, and all the clues that have been given to us. So, only after this can we go to the question. This part here is not the question, this part is just a story. And then her observation is the metal ball bearing was not attracted to the nail. So there could be two possible problems. It could be, or could be more. Maybe both of the metals are made of non-magnetic materials. Or maybe this metal nail is made of a magnetic material, and this one becomes an electromagnet. However, if this is a non-magnetic material, there will be no attraction observed. That will be the second possible reason. The third possible reason is this is a magnetic material, iron or steel, but this metal nail is made of a non-magnetic material, so it does not become an electromagnet. Let's see what are the options given to us. Which of the following could be the possible reasons for Sally's observation? So we're trying to find out options that tell us, yeah, this one will not work as an electromagnet because of the wrong material chosen for this metal nail, or because we want to find out whether the problem lies with the metal ball, that this is made of a non-magnetic material. So the nail was made of iron. No, this is not a problem. If the nail is made of an iron, then this tells us that this becomes an electromagnet that works. So this cannot be the possible reason for the failure for Sally to see any attraction. The wire made of copper. This is not a problem. This simply tells us that the wire is made of metal, and metal is a good conductor of electricity, so electrical current can flow through this circuit. This is not a problem. The metal ball bearing was made of aluminum. Metal ball bearing made of a non-magnetic material like aluminum. Yes, this is a possible reason why this attraction was not observed. There were not enough coils of wire around the metal nail. This is also a possible reason. Why? Because when you are typically asked this question, how to increase the magnetism of an electromagnet, you have two possible answers. One is increase the number of coils around the metal nail, or increase the number of batteries. In this case here, if there are not enough coils of wire, that means that the electromagnet may not be strong enough. This seems metal is quite heavy, you know. So now we have it is C and D. Therefore the answer is C and D. If you have any questions, do leave them in the comments below and I will answer them when I see the comments. Let's go to the next page. Susan had two metal rods B and C of the same size. Metal rod B, metal rod C. Remember, we're trying to understand the story first. We will usually not look at the question, right? Let's understand the story. Now, one of these rods was a magnet and the other one was made from a magnetic material. So only one is a magnet. Now, she wanted to find out which rod was a magnet. Now, this is an important and yet very commonly asked question. What does it mean then? It means that you should memorize the idea behind this and know how to answer this instantly. How do you tell whether a magnetic material or an object is a magnet or not? You must see an observation. Please write this down. And this observation that you should see, can you pause the video here and write it down first on your own, and then you check back against my answer. Have integrity, okay? Just pause it and try it first. So, do you write down repulsion? If you have written down repulsion or repel, that means hooray, you got the right idea. If you have written down attraction, then I'm sorry, you need to revise this topic. She arranged the rods B and C, these two rods, and the magnet PR is a magnet PR. Here is PR this way. That means that this person, Susan, actually rotated this like this way, turn it around, and put it over this side, as shown in the diagram below. Now, Susan was not able to conclude which rod was a magnet from the above setup. So what did she do that was wrong? Right? Choose the correct step she should follow to help her make her conclusion. Now, what could have happened? For example, let's assume this is the North Pole. If this is a North Pole, P is a North Pole, then this is a North Pole. If this is a North Pole, then R is a South Pole. If R is a South Pole, therefore this is a South Pole. Now, she noticed that there is an attraction here. Alright? If let's say B is a magnet, then this must be a South Pole. Isn't it? If there's an attraction, this must be a South Pole. And if she twists this magnet, she turn it around like this and put it here. What if C is the non-magnetic material? Sorry, what if C is the magnetic material? So the whole thing, any part of this can be attracted to a magnet. Of course there'll be attraction. So by looking at this, she can't tell which of the rods is a magnet. Because Susan didn't understand the idea that she must observe repulsion. Help her. So based on the answer at the back of this worksheet, which you must have seen, alright, the answer is 3. Alternate the poles of both magnets to the rods and observe any repulsion. So after doing this, what Susan should have done is, for the same rod B, after she put the magnet here, and notice, oh, there is an attraction. So she should turn this around. When you turn it around, it is like this. You have this, now it's S here, and N here. And if this is truly a South Pole, then there must be a repulsion. Then she will know that metal rod B is actually a magnet. If that is true, when she turns this one around, so this one becomes a North Pole and this one becomes a South Pole. If this is truly a magnetic material, no matter how she turns this, she will always observe an attraction. Right? That's why the answer is 3. Next.